Good morning. Today we are going to discuss a ring counter. Ring counter is a counter. Counter means it is a group of shift registers, and using these shift registers, the output of these shift registers, for example, this is QA, QB, QC and QD. These are the outputs of the four flip-flops, and that together is making a bit pattern, and that keeps on changing, and that is called a counter. Here for example, this is after 1000, the output QA, QB, QC and QD are 1000. After that it will become 0100, then it is 0010, then 0001, and again it is continuing like this. Okay, now this is actually a ring counter. This is a 4-bit shift register, and shift register, as you know, after clock is applied, the content or QA is set as B, and QB is set as C, QC is set as D, and here, as this is a ring counter, here there is a loop. That means output of this D flip flop, the last flip flop is connected to the D input. This is the D input of the first flip flop. D input. These are all negative edge triggered D flip flops, and as you know, after after clock is applied, thus D input becomes the content of A. That means the output of this QA is connected as the D input of this is DB. This is DA. So the output of this flip flop is the D input of the next flip flop, and the D input of this is DC, and this is DD. That means D input of the C flip flop is the output of the previous flip flop. Here the D input of this is the output of this flip flop, and like that. That means here you have a shift register. This is actually, it is a shift register, and one thing you should remember, the output of the last flip flop is connected as the D input of the first flip flop. Okay, that is only difference. Next, we are going to discuss what is preset. When this is an active low signal, signal means when this input is 0, then that will be active. That is why I have given it as preset 0. When that preset signal is turned on, what will happen? The content of this A or this A flip flop will be set. That means here you have two signals. Clear signal is, that is also an active low signal. That means when this clear signal is low, then the content of all the flip flops A, B, C and D will become zeros, or they are reset. And when the preset input of the flip flop is activated, what will happen? Activated, the content of this register or content of this flip flop will become 1, or that will be set. That means this clear is for clearing or resetting this content of flip flops, and preset signal is for setting the content of flip flop. Here, if you are activating this preset, then what will happen? Content of A becomes 1. Okay, for setting that you are using this preset signal. Okay, now say, as you know, this is just like a shift register. This is a 4-bit shift register, and the one and only difference between a 4-bit shift register and this ring counter is here the output of the last stage, output of the last flip flop is connected as the input of the first flip flop. Okay, now I am going to draw the truth table for this. Here this is the truth table. For example, before the first clock cycle is applied, what I am going to do is, you can set either of these for flip-flops. Here also we can have a preset signal. This is preset signal. Here this is active low, and here also we can have a preset signal. Here also we can have another preset signal. That means initially for setting the content of this, we can set any value here, and initially what you are going to apply, you are going to clear all the flip-flops. After that, if you want to set, say it is 0, 1, 0, if you want to set, that means initially what you are going to do is, here if you want to set this as 0, 1, 0, 0, what will happen? 0, 1, 0, 0, then initially you are going to clear this using this clear signal, and after that the PR bar of the second flip-flop will be activated, and when you are activating that, what will happen? That will become 0, 1, 0, 0. Then what is the ring counter? That means ring means it is shifting like this. That means 0, 0, 1, 0, 0 becomes, that means 0 is shifted to this place, 1 is shifted, next 0 is shifted, and the last 0 is shifted to the first position. Okay. Now for the next clock cycle, what will happen? This 0 comes here, this 0 come over here, this one is coming here, and this 0 is going to this place. And now after that, what will happen? This one will go here, then 0, 0, 0. Then next is this one comes here, 0, 0, and this 0 will come to this place. Okay, that means this is 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 1, 0, 0, 1, and next 0, 1, 1, 0, like that. And suppose that if you are starting with, say, 1, 1, 0, 0, if you want to count from 1, 1, 0, 0, what will happen? 1, 1, 0, 0. Then after clearing this using the clear signal, next preset signal is applied for first two flip-flops A and B. Then these two, the content of A flip-flop and B flip-flop will be set as 1 and 1. Then after that, when clock is applied, this one will go here, this one, and this 0 comes here, and this 0 will go back to the initial position. Then after that, this 0 will come here, 1 will come here, this one here, and 0 will go to this place. Next is this 0, this 0, this one, and this one will come here, and like that. That means if you have a ring counter, then what the ring counter does is it goes on shifting. That means shifting to right, and the last bit will be copied to the first flip-flop. The content of the last flip-flop will be copied to the first. That means this just like a ring. That means for initially setting these flip-flops, initially you have to use this preset bar signal, and once it is reset, for every clock pulse it is shifting right. And as it is a ring counter, that means content of A will be will go to B, B to C, C to D, and D to A. That means if these are the A, B, C, and D, D, A, B, C, D. This is how the content is replaced. That means content of A is going to B, content of B is going to C, content of C is going to D, and the content of A is replaced with the output of D. That is a ring counter. And here, say, in this case, in this example, initially we are going to set it as 1, 0, 0, 0. That means content of A. Using this preset bar signal, we are going to set the content of A. And that means here 1, 0, 0, 0. Then when you are shifting, that will become 0, 1, 0, 0. Then again we are shifting like this, 0, 0, 1, 0. Then if you are again shifting 0, 0, 0, 1, and like that, that means Initially 0, as it is a negative edge triggered form, these are the negative edges. These are the negative edges. And when this negative edge, this 1 0 0 0, then for the next negative edge, this 1 will go here, 0 to 0, 0 to 0, and this 0 to 0. Then for the next clock cycle, 0 to 0, 1 to 1, 0 to 0, and 0 to 0. Then for the next clock pulse, 0 to 0, 0 to 0, 1 to 1, and 0 to 0. Okay. Then 0 to 0, 0 to 0, 0 to 0, 1 will go here, and likewise, like that. So this is very important, and the main points you should remember: this is a sequential circuit, and it is a shift register. It is a 4-bit shifter. You can have 5, 6, or 7, and n-bit ring counters can also be there. For every clock pulse, it is shifting the contents. And the contents of these are shifted, and the content of the last flip-flop is copied to the first flip-flop. That is how the name ring. Okay, that's all about a ring counter. We are continuing the Johnson counter. Say again, there's a minor difference between Johnson counter and ring counter. Ring counter, as you know, the output of the last flip-flop is considered as the input of the first flip-flop. Here in this case, as it is a Johnson counter, here what you are going to do is, instead of the output, its complement, that means the output is QD. The output of this is QD, and QD bar, this is the complement of that. That is given as the input to the D input of the A flip-flop. Here that is given as the D input of, that means the last flip-flop, and this is Q bar or QD bar, and the complement of the output is taken, and that is given as the D input of the first flip-flop. Okay, this is Johnson counter, and initially, as you know, Johnson counter has A, B, C, D. All the content of all the flip-flops are zeros. That is why here we have 0, 0, 0, 0. And here the output of this is 0. Initially the output is, here it is 0. That means initially you have 0, 0, 0, and 0. The output QD is 0, so QD bar is equal to 1. That is given as the input to this first flip-flop. So initially you have 0, 0, 0, 0. When the first clock pulse is applied, what will happen? Here this is A. This is dA is equal to 1. So this will become 1. And this 0 is copied here. This 0 is copied to this place. This 0 is copied to this place. Again QD bar is equal to 1. Then during the next clock pulse, that means the first clock pulse, as QA is equal to QD is equal to 0, QD bar is 1, and that QD bar is given as the D input of A, then this will be set. That means here QD is equal to 0, then QD bar is equal to 1. Now here after first clock pulse 1 0 0 0, now what will happen? For the second clock pulse, here this is the content of A, and the content of A is copied to content of B, that is 1. Content of B is copied to C, content of CP is copied to D, and content of this, and that the complement of that will be copied to this place. That means again that is 1. That means 1 1 0 0. That is why you have 1 1 0 0. Again after that, this one is shifted to this place. This one is shifted to this point. Okay. Then 0 is shifted to this point, and the complement of this 0 is given as the input. That's why here you have 1. Okay, that is why here you have 1. That means that will become 1 1 1 0. 1 1 1 0. And during the fourth clock cycle, what will happen? This 1 is copied to here. Here there was a 0. So QD bar is equal to 1, and in that case this will be set as 1, and this one is copied to this one is copied to this, then all of them becomes 1 1 1 1. And when this is 1, QD bar will be 0. QD bar will be 0. Again DA is 0. Then when the next clock pulse is applied, what will happen? As DA is equal to 0, as DA is equal to 0, this becomes 0. This 1 is copied here. This one is copied here. This one is copied here. Okay. And that 0, QD bar is equal to 0, then that 0 is, this one is replaced by 0. So now these are the contents of the 4 flip-flops. Okay. 0 1 1 1, 0 1 1 1, and again QD bar is equal to 0. Then what will happen? During the next clock pulse, this 0 is copied to B, 1 is copied to C, 1 is copied to C, and here QD bar is equal to 0, 0 is copied to here. That means now that becomes 0 0 1 1. That's why we have 0 0 1 1. Again QD bar is equal to 0. During the next triggering, what will happen? This 0 is copied here, this 0 is copied here, this 1 is copied here, and this 0 is copied here. Okay, that means that will become 0 0 0 1. That is why we have 0 0 0 1. Okay, now what will happen? Again QD bar is equal to 0. Now during the next clock pulse, what will happen? This 0 is copied to this place, this 0 copied to here, this 0 is copied to here, and as QD bar is equal to 0, this 0 is copied to this place. And that becomes 0 0 0 0. Now QD bar is equal to 1. That means starting from 0 0 0 0, you have 1 0 0 0, 1 1 0 0, and likewise you have how many states? How many different? 8 different states are there. 8 different states are there, and this is called Johnson counter. In this case, in the case of Johnson counter, there is initially the content of all flip-flops will be 0. After that, you have 8 different stages, 0 1 2 3 etc. to 8 different stages, and as it is a 4-bit Johnson counter, you can have 3-bit Johnson counter, 5-bit Johnson counter, etc. Anyway, there is no need to have that preset signal. Only clear signal is needed. Initially, you have to clear all the flip-flops, and then you have to initiate or you have to do clock pulses only. And one thing you should remember here, in the case of ring counter, feedback is given from the output of the last flip-flop to the first flip-flop. And in the case of Johnson counter, instead of the output, the complement of the output is taken, and that is given as input to the first flip-flop. Okay, now this is the timing diagram. This is the timing. Now the state diagram for this is, here we have 8 states, that is starting from 0 0 0 0, 1 0 0 0, 1 1 0 0, 1110, 1111, then 0111, 0011, and 0001, and back to 0000. So this is the state diagram. Okay. So this is the state diagram for this Johnson counter. Okay. Thank you.